Okay, welcome back, and now let's do some examples involving order of operations. So we've got PEMDAS. Now, again, a couple things to keep in mind. PEMDAS, P is parentheses or any grouping symbols, okay? Exponents or roots. So a root is mapped up with exponents. So exponents and roots are done next, left to right. And then multiplication and division is done left to right. And then followed by, lastly, addition and subtraction done left to right. Okay? So for example, in the first one we have 3 times the square root of 49. So this when we have a 3 in front of a root, there's it's implied multiplication. Okay, so this is 3 times the square root of 49, okay, which is 3 times 7, right? The square root of 49 is 7, and of course this will give us 21. The next one, we have a plus here with the square root of 64. So again, exponents and roots done before addition. So this would be 2 plus, what's the square root of 64? 8. And so now that would equal 10. And again, here we got the square root of 81 divided by 3. So again, roots come before division. Okay, so again, exponents and roots are in the same line. So this would then be simplified to 9 over 3, which equals, 2. No, 3. Okay. Now this here, the reason why I'm showing this to you is it's important because if we have something, some algebra, some addition, subtraction going on under here, some other algebraic operation under the radical, then we want to treat this as a grouping symbol because radical is a type of grouping symbol and acts like a grouping symbol if there's something going on under here. So this is one of those exceptions, just like the fractional bar. Okay? If you've got something going on like 3 plus 6 and 6 times 2 going on, you're going to want to simplify the top and the bottom first. So this is another exception to PEMDAS, right? Here, if there's something going on under the radical like this, then you want to do this first before you do the square root. So in this case here, we would just write this as the square root of 25, and then we can go ahead and then simplify it to 5. Because one thing we cannot do, don't make this mistake, we cannot split this up like that. That would be wrong. That would be absolutely wrong. Okay? Because if you did that, you would be saying that this is 3 plus 4 is equal to 7. And that would not be the case. And you can check that in your calculator. Okay? If you take the square root and put 9 plus 16 underneath there, it'll give you 5. Okay? So be careful of that. Now, the last one here, this one here, notice that we could square this. Now, 38 squared is 1444. And we can divide that by 4, right? That would give us 722, 350, 361, right? But the problem is that square root of 3. 3 is not a perfect square. So guess what? I'm going to put this in the calculator. Okay, now I'm going to show you how I would put it in the calculator to make sure that we get the correct answer. Okay, so let me show you. Okay, so now let me show you what I'm getting here. Okay, so that's what I did. I just put it in. Okay, now if I hit enter, so all I did was I wrote 38 squared times the square root of 3 divided by 4. And so that is what I get. I get the correct answer. Now sometimes the calculator, you have to be careful, you won't put it in right, or it will not follow the order of operations the way you think it will. So what I would do, again, if I set this up again, I'm gonna oops. Is you could put parentheses around the numerator. Okay, that makes sure that, hey, you do the numerator first and then you divide by 4, but guess what? It gives you the same answer. Okay, so the calculator does know order of operations. So if you just put in there, it's going to do the multiplication and division in the correct order, to give you the correct answer. Okay. So just be careful of that. Sometimes it works, sometimes it doesn't. Okay? Have a great day.